friends, a very warm welcome for the discussion of another topic pertaining to CSAT examination. Today's topic is mixtures and alligations. Now, it has been seen of late many questions have appeared, at least one or two, in previous CSAT examinations. So let us learn the concepts and find out what could be the shortest possible method of solving the questions correctly. Let us first of all have a look at one of the questions. In what ratio should a quality of rice costing rupees 7.2 per kg be mixed with a rice of another quality costing rupees 9.4 per kg so that the cost of the mixture becomes rupees 8.5 per kg? So what is happening here is that two types of rice, they are mixed together. Now each of these two types is of different cost, and when they are mixed together in a particular ratio, then the average cost of the mixture is given to us. Now we will have to find out how much quantity of rice of type 1 has been mixed with rice of type 2. So as to say, mixtures and alligations is an extension of ratio, and certain concepts of profit and loss are also used here, as you will see. Now, one of the standard methods that you must have used while solving such kind of questions during your school days would be to assume that type 1 rice is X kg and it is mixed with type 2 rice of Y kgs. Now, the total cost of rice of type 1 will be cost per kg into total quantity in kgs. So cost per kg is given to us as 7.2. Total cost becomes 7.2x because 7.2 is the cost per kg and x kgs is the total quantity of type 1 plus total cost of rice of type 2. Now that shall be cost per kg, that is 9.4 into total quantity, that is y kgs. Now this shall be divided by the total quantity of the mixture when these two types are mixed together. So total cost by total quantity shall give us cost per kg of the mixture. So 7.2x plus 9.4y is the total cost divided by x plus y, which is the total quantity. That shall be equal to the average cost per kg of the mixture, which is already given to us as 8.5. Now, once we have formed this equation, we resolve it and we find out the ratio between x and y. So this shall become 7.2x plus 9.4y equals 8.5x plus 8.5y. So 8.5x minus 7.2x equals 9.4y minus 8.5y. So we're taking this value on the left hand side and this value on the right hand side. So this shall become 1.3x equals 0.9y. X by y shall be equal to 9 by 13, which means the ratio between the two quantities shall be x is to y equals 9 is to 13. So this is the ratio that is desired by the question. Now there is another method which is much faster and shorter and requires lesser amount of calculations. Now that is known as the alligation method. Now this is to be used whenever two types or two varieties of an item are given, their individual costs are given, the average price of the mixture on mixing those two varieties will also be given, and you have to find out the ratio between the quantities of the two varieties. Now in this, type 1 we know is costing 7.2 per kg. Type 2 we know is costing rupees 9.4 per kg, and their average cost is given to us here as rupees 8.5. So this is also known as cross rule. So making a kind of cross here in which you will go from right top to left bottom and left top to right bottom, and we shall subtract the lesser quantity from the greater quantity. That is higher value minus lower value. So here we shall get 9.4 minus 8.5 when you go in this direction from top right to bottom left. And here we shall get 8.5 is the greater quantity and 7.2 is the lesser quantity as we move from top left to bottom right. Now this shall give us 9.4 minus 8.5 as 0.9 and 8.5 minus 7.2 as 1.3. So here itself we get the ratio 9:13. There is absolutely no need to work out through such a longer process wherein you will end up writing a lot and doing a lot of rough work. Kindly remember, the more you write, the more time is consumed while solving a question, which would mean lesser number of attempts, which implies lesser chances of qualifying in the paper. So the desired ratio here is 9:13, where we can also say that 9 kg of type 1 gets mixed with 13 kg of type 2, then the average cost of the mixture becomes rupees 8.5, or maybe multiples of these. 18 kg of type 1 rice is mixed with 26 kg of type 2. Whatever may be the quantities, they must follow the ratio 9:13. Now let us have a look at this question. How much quantity of potatoes costing rupees 10 per kg we mixed with 120 kg of another type of potato costing rupees 2.85 per kg, so that on selling the mixture at rupees 4.8 per kg, a profit of 20% can be made. Now here we will make use of the concepts that we learned in profit and loss. Now in profit and loss, we know that selling price equals 1 plus profit percent or minus loss percent into cost price. So here in this question, the profit is already given to us as 20%. The selling price is also mentioned as rupees 4.8 per kg. Now because for the two varieties of potatoes, cost prices are given, we will have to find out the cost price of the mixture obtained on mixing the two types of potatoes. So the selling price, that is 4.8, must be equal to, profit is given to us as 20%, so it becomes 1.2 times the cost price. So cost price shall be 48 by 12, which is rupees 4. Now after you have calculated the average cost price of the mixture, then we will use the alligation method. So type 1 here is rupees 10 per kg, type 2 let us say is rupees 2.85 per kg, and on mixing these two we have found out the cost price of the mixture becomes rupees 4 per kg. So now what do? From top right go to the bottom left, from top left go to the bottom right, use a cross rule, and in cross rule we will subtract the smaller value from the larger value. So here when we go from top left to bottom right, we find two quantities, 10 and 4. 10 is greater than 4, so 10 minus 4 is what we should get here at this place. And from top right, when we go to bottom left, we find two quantities, that is 2.85 and 4. The greater value is 4, from which we will subtract the smaller value, that is 4 minus 2.85, and we should obtain a value here. So we find that 4 minus 2.85 is 1.15, 10 minus 4 is 6. Multiplying both the sides by 100, we get 115 by 600, which can further be reduced to 23:120 on dividing both the quantities by 5. Now in the question it is given to us that the quantity of potatoes of type 2 is rupees 120 per kg. Now here the ratio point for type 2 is already 120 and the ratio point for type 1 is 23. So we can say that 120 kgs of type 2 shall be mixed with 23 kgs of type 1, which costs rupees 10 per kg. So our answer here should be 23 kgs. Now let's have a look at a question of similar type. How much quantity of sugar costing rupees 20 per kg we mixed with 20 kgs of sugar costing rupees 15 per kg? So again, type 1 cost is given to us as rupees 20 per kg, Type 2 cost is given as rupees 15 and its quantity is also mentioned. So that on selling the resulting mixture for rupees 22.5 per kg, a profit of 25% can be made. So simply we know selling price is equal to 1 plus profit percent or minus loss percent into cost price. The selling price is mentioned to us, that is 22.5. Profit is 25%, so this becomes 1.25 times the cost price. And cost price becomes 2250 by 125. So this shall become 125 into 1 is 125, remainder is 100, combined with a 0 becomes 1000. And 125 into 8 will become 1000. Very simple. 125 into 2 is 250. 250 into 4 shall be 1000. Then half of 250 is 125. 125 into 8 shall be 1000. So we find out the cost price of the resultant mixture, which is rupees 18. Now again, type 1 and type 2, the costs are mentioned, rupees 20 per kg. Here we have it. And rupees 15 per kg, again mentioned here. And the average cost price we have already found out. That is rupees 18. So we shall make use of the cross rule here. So from top right to bottom left, larger value minus smaller value, and top left to bottom right, larger value minus smaller value. 18 minus 5 is 3 and 20 minus 18 is 2. So the ratio here shall be 3 is to 2. But the quantity of type 2 sugar is already given to us as 20 kgs. So we know 2 ratio points correspond to 20 kg. So the multiplier here shall be 10. So similarly, ratio point 3 also shall be multiplied with 10 to give us 30 kgs as the answer. So 30 kg of sugar costing rupees 20 per kg shall be mixed with 20 kg of sugar costing rupees 15 per kg, so that the average cost price works out to be rupees 18 per kg, which when sold at 25% profit, the selling price becomes rupees 22.5. Now another type in mixtures, in a 360 grams mixture of sugar and water, the concentration of water is 20%. How much water should be evaporated? That is, reducing the amount of water with evaporation, so that only 10% water is left in the mixture. Now, in such kind of questions, you should be able to interpret and convert each statement into a mathematical notation. Now, what is the initial concentration of water in this mixture? It is 20%. 20% of what? 20% of total weight or quantity, that is 360 grams. Now we know that 20% of 360 is 72, and it is out of 360 grams, and 72 out of 360 is 20%. So we know that this is the initial situation of water in the mixture. Now what is happening here? How much water should be evaporated? How much should be evaporated? We don't know. We have to find that. So in mathematics, we always assume the unknown quantity as X. So X amount should be evaporated. Evaporated means that much amount should be reduced or subtracted from the initial concentration or initial quantity of water in the mixture. So from 72, we will have to subtract these X grams of water, and this X grams of water obviously is also getting subtracted from the complete quantity. If you have taken out X grams of water from 360 grams of mixture, then how much quantity of mixture remains? It would be 360 minus this X grams of water that you have evaporated. Now after doing this, the concentration of water left in the mixture should be reduced to 10%. So this goes, it should become 10%. Now this is the equation that we have to work towards. So the zeros cancel here. What we get here is 10 multiplied here with the numerator. So it shall become 720 minus 10x equals 360 minus x. So minus 10x and minus x, this becomes 9x when minus 10x goes to the right hand side, and this 360 comes here, gets subtracted from 720 to give us a 360 again. So x here must be 360 by 9. 9 fours are 36, so 40 grams. So 40 grams of water should be evaporated from this mixture. Then the concentration of water left in the mixture would be 10%. Now you can always perform a check here by substituting the value of x in this equation. So it shall become 720 minus 40 by 360 minus x, that is minus 40. So this will become 32, 72 minus 40 is 32, divided by 360 minus 40, which is 320. Now 32 out of 320 is definitely 10%. So you can also make use of choices here. If in choices it is given 36, 40, 45 or none of these, whatever, then maybe you can work out through choices also. But then you should be lucky enough that 40 grams is not given to you in the last choice. Otherwise, the work that you do through the first three choices would be more time consuming. So here we go. We get this equation, and through that, the value of x works out to be 40 grams. In what ratio should milk and water be mixed so that on selling the resultant mixture at cost price, a profit of 16.2 by 3% is earned? Now, very often we find the milk vendor indulging into such kind of fraud, wherein he mixes water in pure milk. Now see, because he's selling the mixture at cost price, hence he is not earning any profit on selling the pure milk. Because if at all, let us say he has bought pure milk at rupees 1000, he's selling the complete mixture after mixing water, he's selling the complete mixture at rupees 1000, out of which he will be selling only pure milk at cost price. So he is recovering the cost price of the milk by selling it at the same price. Then how will he make a profit of 16.2 by 3%? Well, that is to be made on selling water at the cost price. By that, I mean, when he sells the complete mixture, 100% of pure milk gets sold at cost price, no profit, no loss. But that water that he has mixed will increase the quantity, the overall quantity of the mixture. And that water is being sold and earning him the profits. So 16.2 by 3% we know is 50 by 3, because 16.2 by 3 we know 16 threes are 48 plus 2, 50. So 50 by 3. So hence if this is 100 is 250 by 3, this 3 goes here, gets multiplied, which gives us the ratio as 6:1. Now please be very careful. The question is, in what ratio milk and water be mixed? So milk is to water is 6:1. That is 6 portions of milk and 1 part of water. They should be mixed together so that even if this mixture gets sold at cost price, still a profit of 16.2 by 3% would be made. If the question would have been, in what ratio should water and milk be mixed together? So kindly be alert and aware about the order in which these two items have been written. So first milk, then water. If the question would have asked the ratio between water and milk, in that case water is to milk should be in the ratio 1:6. So just be very careful. Your answer here is 6:1, not 1:6. Alok purchased 20 kgs of rice at rupees 6.5 per kg and 30 kg of another type of rice at rupees 8.5 per kg. He mixes both the types of rice and sells the mixture at rupees 9 per kg. How much profit did Alok earn in this transaction? Now the selling price is given to us as rupees 9. Profit percent is not mentioned. That is why we cannot directly calculate the cost price of the mixture. So we will use our standard method in this case. That is 20 kgs of rice at rupees 6.5 per kg plus 30 kg of rice at rupees 8.5 per kg is the total cost of the mixture. Now the total quantity of the mixture shall be 20 kgs of first type of rice plus 30 kgs of second type of rice. and this shall give us the average cost of the mixture per kg. So let us do the calculations here. This shall be 130 and 255 by 50 shall be 385 by 50. So 5 sevens are 35. Another 5 combines, so it becomes 35 again. So 7.7 per kg. Now the profit per kg that he makes is selling price per kg minus cost price per kg. That shall be rupees 1.3 per kg. Total quantity here we already know is 50 kgs. So total profit earned by him shall be 1.3 into 50, that is rupees 65. So by the same logic, this is what we have as the answer. Now Ram purchased 4 dozen apples at rupees 12 per dozen and 2 dozen apples at rupees 16 per dozen. So cost price of 2 types of apples is already mentioned to us here. At what price per dozen should he sell all the apples to earn a profit of 20%? Again, we need to find out the average cost. We are not able to use cross rule here because we need the in-between value. We can have the two values here on the right and left top side, but then we have to have a value which is the average cost of the mixture in between. Then by cross rule, we will find out the ratio between the quantities. So simply 4 dozen apples costing rupees 12 per dozen plus 2 dozen apple costing rupees 16 per dozen shall give us the total cost of the mixture of these 2 types of apples divided by total quantity of this mixture of 2 types of apples. That shall be 4 dozen here plus 2 dozen here, which will be 48 plus 32 by 6 equal to 80 by 6, which is further on 40 by 3. Now let us keep it at this. This is, let us say, the cost price per dozen of the mixture of 2 types of apples. So selling price is what we need to find out, which we know is 1 plus profit percent or 1 minus loss percent into cost price. So hence selling price here shall be equal to, profit is given to us as 20%. So 1.2 times cost price we already have found out to be 40 by 3, that is 40 by 3. So the selling price here happens to be 3 into 4 is 12. So 0.4 is what we get here. So 0.4 into 40, 4 4s are 16. So selling price here will be 16 per dozen of apple. So this should become our answer by this process. In 300 grams of mixture of sugar and water, 40% is sugar. So what do we have here? Sugar and water. What is the ratio? Sugar is 40%. Then water is 60%. Because the total mixture would be considered as 100%. And this 100% of mixture is in actual 300 grams. So what is the multiplier? It is 3. 100 into 3 is 300. So 60 into 3 is 180 and 40 into 3 shall be 120. So there is 120 grams of sugar and 180 grams of water in this 300 grams of mixture of sugar and water. Now how much more sugar should be mixed in this mixture so that the concentration of sugar becomes 50% in the mixture? Now, what is the initial situation? We need to find out how much more quantity of sugar should be mixed. So let us take the initial quantity of sugar in the mixture, which is 120 grams out of a total of 300 grams. Now this we know is 40% of the mixture. 120 out of 300 is 40%. 4 3s are 12. Now, how much more sugar should be mixed? How much more sugar should be mixed? We don't know. We have to find that. So let us assume that as x grams. So x grams sugar, which will increase the total quantity of sugar in the mixture from 120 grams to 120 plus x grams. And the total quantity of mixture will also increase from 300 to 300 plus x grams, because x grams of sugar, we are just adding it into the mixture. Now, on doing this, what happens? Now, the concentration of sugar becomes 50%. So this is the equation that we need the most. this will be 1 by 2. So 120 plus x has to be multiplied with this 2, becomes 240 plus 2x equals 300 plus x. Hence x equals to 300 minus 240, that is 60 grams. If you want, you can perform a check also by substituting the value of x in this equation. That is 120 plus 60. The value of x here is now 60. By 300 plus 60 is 180 by 360, which is definitely 1 by 2. And this is the value that we get here. So absolutely fine. So this is one way, as we have been discussing, to solve this question. Now the other one here is, you know that the amounts of sugar and water in this mixture are 120 and 180. Now you are just adding more amount of sugar. The amount of water or the quantity of water in this mixture will remain the same. That is 180 grams only. Now it is because the quantity of sugar is increasing. That is why its concentration is increasing from 40% now to 50%, because you're adding x grams of sugar to this mixture. Now, when the ratio is 1 by 2, or let us say the amount of sugar is half, the amount of water will also constitute the other half of the mixture, which means the ratio between sugar and water should be 1:1. They're equal. They're equal amounts. That is why half part is sugar, half part is water. So in actual, we should add 60 to this so that the ratio here becomes 1:1. So directly you can find out that 60 grams of sugar should be added to the mixture, and you won't require these calculations. So that would actually decrease your workload as well as the time consumed in working out. So these are the two alternate methods, as you can see. In 35 liters of a mixture, the ratio between milk and water is 4:1. How much water should be mixed in this mixture so that this ratio becomes 2:1? Now once again, milk is to water. Ratio is given to us as 4:1. That is 5 ratio points. The total amount of mixture is given to us as 35 liters here in the beginning of the question. So the multiplier here shall become 7. So when we look at the actual quantities, this shall be into 7. This shall be into 7. This is 28 is to 7. 28 plus 7 is 35, and 28 is to 7 is 4:1. Now how much water should be mixed in this mixture? Which means the quantity of milk in this mixture, even on adding more water, the quantity of pure milk in this mixture will remain unchanged. You're not adding or removing milk from this mixture. You're just adding more water. So the amount of milk here will remain the same, that is 28. But you are adding some amount of water here. After that, the ratio should become 2:1. So it's very simple. 2 into 14 is 28. So 1 into 14 shall be 14 now. So how much will be the value of x? Obviously, it has to be 7 liters. Now the ratio is 28 is to 14, which is 2:1. So simply by looking at the final quantity and the final ratio, you can easily find out the quantity of water to be mixed, which is 7 liters. Now look at this question. A milkman takes out 11 kgs of pure milk from a vessel and replaces it with the same amount of water. Same amount, that is 11 kgs of water. So from a vessel of pure milk, the milkman is taking out 11 kgs of pure milk, and then is replacing it with 11 kgs of water by putting back 11 kgs of water into the vessel. Now he repeats this process 2 more times. So after the first process, when he replaced 11 kgs of pure milk with 11 kgs of water, after that he has repeated this process 2 more times. If initially there was 10 kgs of pure milk in the vessel, then how much quantity of milk will be left in the vessel after these 3 processes have been completed? Now, these are very commonly asked questions, and let us try and understand this particular time in a better way. Now see, the amount of liquid in a vessel, let us say, is x units. Let us assume that. If y units of that liquid is taken out and then is replaced with the same amount of water, and then y units of the mixture is removed and replaced by same amount of water, and this process is repeated n number of times, then the amount of liquid remaining in the vessel will be given by the formula x into 1 minus y by x raised to n, where what is x? It is the initial quantity. What is y? Quantity taken out and then replaced by the same quantity of water. And what is n? It is the number of times the process is repeated. Now to the previous question, let us apply this formula. So the total quantity of milk initially in the vessel is given to us as 110 kg. So the value of x here becomes 110 kg. Now y gives you what? The amount of milk taken out of the vessel and then replaced with water. So here 11 kg of pure milk or the mixture is being taken out. So the value of y here is 11 kg. And the number of times this process is repeated, after the first time, 2 more times. That means the value of n here should be equal to 3. So just simply by substituting these values into the formula, what we get here is 110 into 1 minus 11 by 110 raised to 3. So 110 into 9 by 10 whole cube, which is 729 by 1000, that is 8019 by 100, 80.19 kg is the amount of milk which will remain in the vessel. See, the total amount of the mixture will be 110 kgs only, out of which 80.19 kg is milk and remaining is water, because 3 times we have added water into this mixture. Now look at this question. Now this is a similar kind of a question, but with a new twist here. And what is that? A milkman takes out 100 liters of pure milk from a vessel and replaces it with the same amount of water. Next time he takes out 200 liters of the mixture and replaces it with the same amount of water. Finally, he takes out 300 liters of the mixture and replaces it with the same amount of water. Now, if initially there was 1000 liters of pure milk in the vessel, then how much milk is left over in the vessel? Now, unlike the previous type of question wherein the amount of milk or mixture taken out was 11 kg replaced with same amount of water, every time 11 kg was taken out in the previous question, this time different quantities of milk or mixture is being taken out of the vessel. Now let us say the amount of liquid in a vessel is x units initially, same as the previous case. If y1 units of that liquid is taken out and then is replaced with the same amount of water, then y2 units of the mixture is removed and replaced by same amount of water, and then y3 units of mixture is taken out and is replaced with the same amount of water, and this process is repeated n number of times, then the amount of liquid remaining in the vessel will be x into 1 minus y1 by x into 1 minus y2 by x into 1 minus y3 by x. Because every time a different quantity is being removed, which also means every time a different quantity of water is replacing the mixture. So the only difference is that y1, y2 and y3 represent the different amounts or quantities of liquid that has been removed from the vessel. Now, had y1 equal to y2 equal to y3 been there, then we would have used the previous formula only, that is x into 1 minus y by x raised to n. Now, this n here is getting distributed into 3 parts because every time a different quantity is removed. And that is why we are getting 3 different values of y here. That is the amount of liquid removed from the vessel. Now let us apply this formula to this question. So it is given to us that initially there is 1000 liters of pure milk in the vessel. So the value of x here becomes 1000 liters. First, 100 liters of pure milk is taken out from the vessel. So y1 becomes 100 liters and is replaced by the same quantity of water. Then 200 liters a different quantity is taken out. So that would be Y2, which is given to us as 200. Then 300 is taken out. So Y3 is 300. And obviously these are replaced by the same quantity of water. So we have the formula here to find out the leftover milk. 1000 into 1 minus 100 by 1000, 200 by 1000, 300 by 1000. So you remove the zeros here. First, it becomes 1 minus 1 by 10, 2 by 10, and 3 by 10. On resolving these, 1 minus 1 by 10 is 9 by 10, 1 minus 2 by 10 is 8 by 10. Now, 2 by 10 I did not reduce to 1 by 5. Reason, easily you can locate that in the denominator, you would find 10 into 10 into 10, which will cancel the 1000 in the numerator. So why to increase the number of steps here? Alright, so 1 minus 3 by 10 is 7 by 10. So simply, these 10s, they cancel this 1000, and we are left with 9 into 8 into 7. That is 9 into 56, which is 504 liters. Now this will be the quantity of pure milk which will be remaining in the vessel. Alright guys, so kindly do revise and go through the basics as well as the varieties that we discussed today. We will meet again and discuss another topic in the next session. Till then, please work hard, stay safe. Thank you so much.